Hello and welcome back to the Sports Biomechanics lecture series, as always supported by the International Society of Biomechanics in Sports and sponsored by Vicon. I'm Stuart McCurlane-Naylor from the University of Suffolk, and today I'm joined by Kristin Sainani, who is an Associate Professor at Stanford University and also a health and science writer. So Kristin has already delivered a lecture as part of this series on statistics in sports science, which is actually the most viewed lecture in the series. So I guess we can say, yeah, she's backed by popular demand. But Kristin has, as well as her statistics, she has a very popular Coursera course called Writing in the Sciences, which I've linked to in the description below the video. And yeah, she's very kindly agreed to do a second lecture today on writing, or scientific writing specifically. So thank you very much, Kristin, and over to you.
Thanks, Stuart, and thanks for inviting me back to speak. And yes, I'm going to talk about a totally different subject today, which is scientific writing. But I think good writing is just as important, actually, as good statistics when it comes to improving science. So I'm going to start here with just some high-level tips for your writing. So first of all, when you're writing, keep in mind that the point of writing is to convey your idea to a reader. And unfortunately, I think scientists, especially young scientists, when they sit down to write, they get caught up in other things, like trying to sound like they're part of the club, trying to impress their advisor. And that distracts from the point of writing, which is to inform your reader. You also want to write as clearly and concisely as possible. But I feel like we all had like a 10th grade English class along the way where we were told that we had to write a 10-page term paper. And none of us at that age had 10 pages worth of ideas. And so what did we all learn to do? We all learned to pad our writing with unnecessary words. So now you got to go back and untrain yourself of that habit, because you want to get your idea across as quickly and efficiently as possible to your reader. And then finally, try not to bore your reader. And this is something we, I think, almost never think about when we're writing scientific paper. But I'm trained as a journalist, and I spend a lot of time writing for general audiences. And when you write for general audiences, this is actually always at the forefront of your mind, that you are trying actively to engage your reader. And unfortunately, I think when we write in science, we rarely consider our poor reader on the other end. But you and I are all poor readers, right? If you're like me, you probably have a stack of papers on your desktop that you need to read, and you may be dreading reading those because you know they're going to be tedious. And I actually don't think that the scientific literature has to be tedious. I think we could do a lot better job in making the writing engaging. So I'm going to start now with some examples. And I think these examples actually are just very typical of what you see in the scientific literature. So this first one comes from a paper that was in a top oncology journal. And I was writing about it a few years ago because I was doing a magazine story on it. And it was some very interesting and important science. But this was the first sentence of the introduction section. So it says, adoptive cell immunotherapy is based on the ex vivo selection of tumor-reactive lymphocytes and their activation and numerical expression before reinfusion to the autologous tumor-bearing host. And I don't know about you, but I have trouble parsing that sentence. I have enough background in biology that I understand what each one of those individual words means. But when you put them together like that, I have a hard time following it. My favorite part of this example is the autologous tumor-bearing host. So step back for a minute and think, like, what is the autologous tumor-bearing host? What are we talking about there? Of course, we're talking about the patient, right? When I was a graduate student, I'd see writing like this, and I'd struggle through papers. And as a graduate student, I would think when I had trouble reading a paper that the problem was with me, right? That like, I'm not smart enough. I haven't had enough training yet. And that's the reason I can't understand this paper. I am now a lot older and wiser. And so I now know that, in fact, if I'm having trouble reading a paper, the problem is not with me. The problem is with the poor writing in papers. And I really like to make this point to young scientists, that if you are struggling to read a paper, don't assume that the problem is with you. The problem is with the poor quality of writing in the scientific literature. And so I always tell young scientists to kind of have this mantra in your head as you're reading papers and struggling with them. Remember, it's not you, it's the author. So just kind of keep thinking, it's not me, it's the authors, right? The quality of writing in the scientific literature is poor, which makes a lot of these papers really hard to read. I actually had to understand this paper because I was writing about it for a general audience. So what did I do? I kind of Googled around and I found a great definition actually of this therapy in Nature Reviews Cancer. And so I'm going to show you this alternate definition. It says adoptive cell therapy uses a cancer patient's own T lymphocytes with anti-tumor activity expanded in vitro and reinfused into the patient. And that says everything that the first sentence says, but it does so much more clearly. All right, this is something, this was the aim statement of a paper that I was editing a few years back, and it says, as such, the purpose of this study was to present the development of a theoretical model of factors and potential relationships and processes explaining variation in workability based on a thorough assessment of biopsychosocial variables in patients with cervical reticulopathy. Now, you can hear that that's very wordy, right? My favorite part of this example actually is the theoretical model of factors and potential relationships and processes explaining variation. So step back from that for a minute and think about what is a model we use to explain variation? What is a very simple way to say that? What is a regression model? That's a very long-winded way of saying regression model. Actually, when I was advising the authors on how to edit this, I realized that in an aim statement, we usually don't talk about our statistical method. So I actually had them drop that regression model altogether. And I just told them to revise this to the aim of the study was to identify risk factors for impaired workability in patients with cervical reticulopathy. That's all the study was doing. All right, this next example actually comes from a published paper in a top sports medicine journal. And I love this example because it's about napping. And napping, let's all face it, is not complicated, right? It is not astrophysics. But this example illustrates how sometimes we end up overcomplicating things in science. So it reads, considerable attention has been paid to napping as an effective countermeasure for arousal decline and for improving cognitive performances. The previous literature has demonstrated that naps less than 30 minutes undermine the deleterious impacts of sleep deprivation that affects arousal and performances. It has also been reported that naps enhance arousal levels even when the quality and the quantity of the previous nocturnal sleep are adequate. It would be of interest to mention that the differences in results found in previous researches depend on the diversity of factors that determine the benefits acquired when taking short naps. Indeed, factors like the quality of prior nocturnal sleep, sleep architecture, and temporal placements of the nap during the day may determine the extent of benefits gained through short naps. And I think when you read that out loud, you can again hear how wordy it is. It's actually really hard to follow. It seems like the authors are working really hard to make you think that napping is more complicated than it is. My favorite part of this one is the temporal placements of the nap during the day. Because what do they mean actually? They just mean the timing of the nap. So I rewrote this one just for fun, just to take a stab at an edit here. And I rewrote that to short naps improve alertness and cognitive performance in individuals who are sleep deprived as well as those with adequate nightly sleep. However, the extent of the benefits may vary depending on factors such as the quality of the prior night's sleep and nap timing. So I think I've captured all of the ideas in the original paragraph, but in much shorter form and easier to follow. All right, just one more example here. This one actually comes from computer science, and it says, certainly the usual methods for the emulation of small talk that pave the way for the investigation of rasterization do not apply in this area. In the opinions of many, despite the fact that conventional wisdom states that this grand challenge is continuously answered by the study of access points, we believe that a different solution is necessary. Now, you might be sitting there thinking, okay, I'm not in computer science. Of course, I'm not going to understand this. This is computer science talk. It's out of my area. I actually have a confession to make, though. This one is actually a fake paper. So this is not a real paper. This was a nonsensical paper automatically generated by a computer. A group of scientists at MIT put out this website called the SciGen website, and it automatically generates fake scientific sounding papers. They did this to see if they could get these papers accepted in conferences, and guess what? The papers were accepted, including the example that you see here. I like this example, though, because I think it illustrates just how poor the quality of writing is in the scientific literature. We are so used to complicated and hard to parse writing that we actually have trouble differentiating between real scientific writing and just complete nonsensical prose. So remember, when you're having trouble reading paper, it's not you, it's the author. So what do all these examples share? They are hard to read. They are boring. They contain a lot of gratuitous jargon, like the autologous tumor-bearing host. They use big words to describe small ideas, temporal placements instead of timing. And they have a lot of vague or completely meaningless prose. And there's actually empirical evidence that the problem is getting worse, not better. And so it was a great study in eLife in the year 2017. The researchers took 700,000 abstracts from 123 journals in 12 fields, and they ran them through some automatic readability checkers. And the graph over here shows is readability is on the y-axis, higher scores are better. The x-axis is time, 1880 to 2015, and you can see that readability is going down in the literature. Just to give you a sense, one of the scales they used was called the Flesch Reading E-Scale. And just for fun, if you want to, there's a link here, www.checktext.org. You can go paste your own writing into the box there. It will check your writing for plagiarism. It will also give you a readability score. So just for fun. This Flesch Reading E-Scale, it's a very simple metric. It's certainly not perfect, but what it looks at is just the total number of words per sentence and the number of syllables per word. That's all. So of course you could have a long sentence with really big words that was actually readable. So this is just one metric, but it's a pretty good proxy a lot of times. It's a 0 to 100 scale. 100 is very easy. 65 is plain English. Below 40 is considered difficult. Below 20 is considered very difficult. So where are we in the scientific literature? So you can see that in 2015, the average score was 10, which I would argue is pretty terrible. Just to give you a benchmark, that immunotherapy example that I showed you, that scored a 12.4 when I put it in the checker. The cervical reticulopathy scored 14.9. So those examples are actually very much in line with the current scientific literature. In contrast, the rewrites I showed you of those two examples scored 37. So it would still be considered difficult, but a lot more readable. And imagine if we could bring up the entire scientific literature to that level of readability. Imagine how that would change and improve science. So I'm going to spend most of this talk giving you some very specific tips for how to improve your own writing. But if you'll permit me, 2 minutes on my soapbox here. One of my missions in life is to get scientists to write better. And I believe in this because I think poor scientific writing does a lot of harm in science, but it's one of those kind of under-recognized problems that we talk about, every now and then, but we really never do anything about. I think poor scientific writing does a lot of harm in science. So I think it's obvious that if it takes you 4 times as long to read a paper than it should, that's going to slow scientific progress. I also think that poor scientific writing plays an important role in the reproducibility crisis. So we spend a lot of time wringing our hands about bad statistics and bad study design, but we rarely talk about the role of poor scientific writing in reproducibility. But if we are so used to complicated, hard to parse prose, it actually makes it really easy for errors and, frankly, BS to slip through sometimes. It also makes the writing, less transparent. If you can't understand it, then you lose transparency. I think poor scientific writing also enables pseudoscience to flourish because it's really easy to make up a nonsensical but scientific sounding argument just by stringing some jargon together. And it's hard for most people to differentiate that nonsensical argument from a real scientific argument because they sound kind of similar. This ultimately undermines public trust in science, which is a huge problem in the current moment in the world, as you all know. And I think poor scientific communication also does a disservice to young scientists, because I think there are a lot of young scientists out there who are feeling really lost when they try to read the scientific literature, or they're feeling really lost when they're sitting in seminars. And they think that the problem is with them, when in fact, the problem is with the poor state of communication in science. And of course, this leads to things like imposter syndrome, and it leads to really talented people dropping out of science. So what can you do about it? So first of all, don't emulate what you read in journals. So write a different way. Don't assume that just because it's published, that's the way you should write. You really need to care whether anyone reads or understands your work. I feel like a lot of times we get really caught up in publication, and the end goal essentially becomes just to publish your work. And we forget that the point of science is to advance knowledge, which requires other people, as many people as possible, to be able to read and understand our work. It's a really good tip when you're sitting down to write. Before you sit down at the computer to write, work out what it is you're trying to say. And so I often sit down and edit things for students, and I might get stuck on a paragraph, and I'll say to them, so what were you trying to say in that paragraph? And they will say, oh, I'm not really sure what I was trying to say. And I was like, aha, that's the problem. If you don't know what you're trying to say, it's really hard for you to convey that clearly to a reader. And so you can do a lot of brainstorming away from the computer. I do a lot of brainstorming about my writing, like when I'm driving or out running. That's a lot easier than doing it at the computer. you have to understand the science really well in order to be able to explain it with plain English. I think a lot of people don't realize that, but it's much easier when I'm writing for scientific articles and I can throw in a bunch of jargon. It's much easier for me to explain the science. When I write for general audiences and I have to use more plain English, I have to think really carefully about how the science works. So it actually forces you to understand the science better if you're explaining it in a way that people can understand. We already talked about writing to inform, not to impress. In clear writing helps with transparency. So you have to, of course, be confident in your methods in order to be transparent and write them clearly. I have to say, I do a lot of statistical review. And sometimes when I'm reading a statistical methods section, I think, I wonder if like the authors were intentionally obscuring their methods and making it really hard for me to understand, because maybe they didn't feel confident that they'd done the statistics right. So they figured if they made it really hard to understand, then nobody could question it. So you should be confident in your methods, be confident in what you do, be confident enough to write it clearly. And then finally, learn principles of effective writing and practice them. So there are some really easy principles of effective writing that I can teach you. I'm going to talk about those in the next 30 minutes of the talk. These are not things that are hard to learn. They're actually quite simple, but we often neglect these in graduate school. They often are not taught in graduate school. So learn these principles of effective writing, and of course, the way to really become a good writer is to practice. So 2 key principles of effective writing that I think can make a huge difference in the quality of your writing is learning to cut the clutter from your writing, and also writing with verbs. So I'm going to go over both of these. So starting with cutting clutter. So this is a sentence from a paper I was editing a number of years back. It says, this paper provides a review of the basic tenets of cancer biology study design, using as examples studies that illustrate the methodologic challenges or that demonstrate successful solutions to the difficulties inherent in biological research. So when you read that out loud, you can hear there's a lot of extra words. I want to go through now line by line, word by word, and just see what we can cut. So starting with, this paper provides a review of. Think about how you might shorten that, right? Instead of saying that, we could just say this paper reviews. So this is an example where we've got a nice verb, to review. We turned it into a noun, a review, and we paired it with a boring verb, to provide. There's no reason to do that. So just say, this paper reviews the basic tenets of cancer biology study design. So think about if there's anything you'd be okay with cutting there. How about if we get rid of the basic tenets of? So basic tenets of is one of those kind of really vague things that just doesn't add a lot of information for the reader. When you cut it, you don't miss it because it wasn't adding anything anyway. This paper reviews cancer biology study design. And then we get using as examples studies. Well, that's a little bit awkward. You can hear that when you read it out loud. We don't need both examples and studies. So we could just say using examples that illustrate. So using examples that illustrate the methodologic challenges. So I'm going to cut the word methodologic there too, because again, I think it's a very vague word. It doesn't add a lot for a reader. And remember, we've already said that we're talking about study design. So when you're talking about study design, it's implied that you're going to be talking about methodology. Trust your reader to get that. You don't need to repeat it. So then we get that illustrate challenges or that demonstrate successful solutions. Think about that for a minute. Illustrate and demonstrate, those are synonyms. So I always picture the author of this paper sitting at the computer and saying, oh my gosh, I've already used the word illustrate. I don't want to repeat myself. So they went to the thesaurus and they found demonstrate. So I want you to catch yourself next time you find yourself doing this. That is going to the thesaurus to avoid repeating yourself. A lot of times you actually just simply don't need the second instance of the word, because here we can use illustrate to carry over to both challenges and solutions. So we don't actually need demonstrate at all. So we can just cut all of that. That illustrate challenges and solutions. Notice I also cut the word successful there. So why did I do that? Well, successful solutions is redundant. There is no such thing as an unsuccessful solution. So when you say solution, successful is implied. And then we get to the difficulties inherent in biological research. I decided to cut all of that because difficulties is just a repeat of challenges. In biological research, well, we already said we're talking about cancer biology, so we don't need that repetition either. So we can strip this down to this paper reviews cancer biology study design using examples that illustrate specific challenges and solutions. And you can just hear how much weight we dropped from that sentence. All right, one more example. As it is well known, increased athletic activity has been related to a profile of lower cardiovascular risk, lower blood pressure levels, and improved muscular and cardiorespiratory performance. So again, we can go through and cut some words. So as it is well known, we often, in the first draft especially, like to start our sentences with this kind of getting into the sentence. Go back and cut those. It's totally not necessary. You can indicate something is well known by putting citations, right? So increased athletic activity has been related to, I kind of prefer is associated with, that's just stylistic. And then we get a profile of lower cardiovascular risk. Think about that for a minute. Do we need a profile of? Does that add anything? Can we just say lower cardiovascular risk? And then we get lower blood pressure levels. Well, we don't need the word levels there, right? Just lower blood pressure. And then we get improved muscular and cardiorespiratory performance. Think about that for a minute. What do they mean there? What is that? That's just a really fancy word for saying fitness. So if you mean fitness, just say fitness. So this pairs down to increased athletic activity is associated with lower cardiovascular risk, lower blood pressure, and improved fitness. Now, arguably, in this case, we could actually go one step further and be a little bit more direct. So I think we would actually be okay saying increased athletic activity lowers cardiovascular risk and blood pressure and improves fitness. That, of course, requires a stronger level of evidence. We're making causal claims there. But I think in this case, we probably do have that level of evidence. So when you can be direct, go ahead and be direct. So I showed you these examples about napping and cervical reticulopathy earlier. I showed you my edits of those, but what I'm showing you here is the track changes, showing you my edits, just to give you a sense of how much I was able to cut out of those two. Everywhere you see the red crossed out, those are all the things I was able to drop. So what's the kind of clutter that you should look out for? So first of all, dead weight words and phrases. These are just totally unnecessary. So things at the beginning of a sentence, like, as it is well known. It has also been reported that. It would be of interest to mention. You just totally don't need those. Again, on a first draft, they often sneak in. That's okay. Go back and cut them. Empty words and phrases. These are things that are so vague, so general, that they just don't add anything, any information for the reader. Basic tenets of processes. They're empty words. And one of my all-time favorite quotes in writing, this is from William Zinsser, who wrote a classic book on writing well. And he says, some words and phrases are blobs. And I just love that description because basic tenets of is a perfect, a blob is a perfect description of basic tenets of. That is very blobby, right? A few years ago, I discovered that there is a creature called a blobfish. And I love the blobfish because it's a great visual of what blobby words and phrases look like. So you should have that picture in your head when you write basic tenets of and processes. You're putting a blobfish in your writing. And actually, at my home, my kids are learning to write. And so I edit their work sometimes. And I will go through and underline very general things where they're not being specific enough. And I will say blobfish, blobfish, blobfish. And we actually use the blobfish in my house as the representation of empty words and phrases. You should also look out for long words or phrases that could be short. Always use the shorter version. Usually these words are not the critical words in the sentence, so why waste time on them? So instead of saying temporal placements of the nap during the day, just say the timing of the nap. You should look out for unnecessary jargon, of course, and in a scientific article, you're going to have to use some jargon, but don't use it gratuitously, like muscular and cardiorespiratory performance or autologous tumor-bearing host. Another one of my pet peeves is unnecessary acronyms and abbreviations. So we have this terrible habit in science now of anytime you repeat a word more than like 3 times, you turn it into an abbreviation. And so you see all these abbreviations running around in papers. And as a reader, I really get annoyed by those abbreviations. And remember, I might be reviewing your paper. So you don't want to annoy your reviewer, right? Because every time I see these non-standard abbreviations, they're not something that's familiar to me. So what do I have to do? I have to sit there and translate every one of those abbreviations. That slows down my reader, wastes my time. So this is one that, is editing or reviewing a few years ago. It says spinal muscle fatigue is common in people with LLA because decreased spinal muscle endurance and strength has been reported in persons with TFA and TTA with LBP. I don't know what any of those are. We don't For repetition, redundancy, we saw a number of examples in that study design sentence, successful solutions, illustrate, demonstrate. Don't repeat yourself. Trust your reader, doesn't need that repetition. And adverbs vary really quite generally. I love adverbs in speaking, like in emails. I will use a lot of reallys and generallys. But in formal writing, you want to strike those because they don't add anything to the writing. So I included a few examples from my own writing today just for fun. So when I was younger, I wrote a health column for Allure magazine for a decade. And I worked with an absolutely wonderful editor there, and I learned a lot from her. So here's an example of when I used a blobfish in my own writing, and I'll show you how she edited it. So I wrote, a few participants reported skin irritation. Well, skin irritation, it's kind of general, it's kind of vague. My editor changed that to, a few participants reported facial burning or tingling, which is so much more evocative. You can picture that in your head. Now notice she added 2 words, so it's actually okay to add words as long as you're adding information. There's lots and lots of examples of where we use long words and phrases where we could have used a short one. So just a few examples, you can come up with 1,000 of these. Instead of saying a majority of, you could just say most. Instead of a number of, how about many? Are of the same opinion, that's just agree. Less frequently occurring, that's rare. All 3 of them, just the 3. Give rise to, just cause. Due to the fact that, because. Have an effect on, effect. And again, you can come up with a lot of these. I think, again, this goes back to like 10th grade English, where we had to pad our writing with lots of extra words. We got in the habit of using more words than was necessary. All of these kinds of words and phrases, they're not the important part of the sentence. They're not conveying the main idea. So you don't want to spend any more time on them than you have to. Go with this short version. This also really helps if you have an abstract with a word limit and you need to cut down words. So one more example of cutting extra words. So this was a sentence I was editing a few years ago. It says, brain injury incidence shows 2 peak periods in almost all reports. Rates are the highest in young people and the elderly. Now, I think that's a pretty good sentence. We can all understand it. It's not bad. But compare that to the edited version. The edited version says, brain injury incidence peaks in the young and the elderly. That is much more powerful because it conveys the same idea in about half the words. So I have examples here. If you're watching the lecture live, you can kind of do this quickly in your head. But if you're watching the videotaped version, you might want to pause the video actually and attempt this on your own. So here's an example where we could practice cutting clutter from a sentence. So it says, an IQ test measures an individual's abilities to perform functions that usually fall in the domains of verbal communication, reasoning, and performance on tasks that represent motor and spatial capability. So again, reading it out loud, it's a really good tip to read your writing out loud, because you can hear that it's unnecessarily wordy. What do we really want to say? We want to say an IQ test measures certain things. It measures verbal communication, reasoning, and motor and spatial capabilities. The rest of the sentence we can drop. So we could cut it to something like, an IQ test measures an individual's verbal, reasoning, and motor and spatial abilities. All right, so second tip for you today is to write with verbs. The English language actually runs on verbs. So to the extent possible, if you can focus on your verbs, that can really help improve your readability. 4 tips I have: use the active voice rather than the passive voice. I'll go into that in detail in a minute. Use strong verbs. Don't turn verbs into nouns, and don't bury the main verb. So I'll go over each one of these now. So first of all, active voice versus passive voice. Might be a while since you've thought about this. So just a reminder, active voice, we say things like, she throws the ball. That's the normal way we talk. So the agent, the person throwing the ball, is at the beginning of the sentence. The thing being acted upon, the ball, is at the end of the sentence. That's our normal way of speaking. To put that in the passive voice, you invert that structure. You put the ball first and her at the end. So you say the ball is thrown by her. Obviously a very awkward way to talk, and yet we slip into this in scientific writing a lot. So how do you recognize passive verb? If it's been a while since you've thought about it, a really good tip for recognizing when you've slipped into the passive voice is that a passive verb always has a form of the verb to be in there. So is, are, was, were, be, been, am. So like the ball is thrown by her. So you're looking for a to be verb that's been partnered with a main verb that's in the past tense. So it's going to be in the past tense. That verb, of course, has to take an object. So if you say she runs, like the activity of running, you can't turn that into the passive voice. But if you say she runs the company, now we've got an object, you can turn that into the passive voice. The company is run by her. All right, so let's practice a little bit of recognizing passive voice. Again, you're looking for those to be verbs as a flag to kind of help you if it's been a while since you thought about passive voice. So those are is, are, was, were, be, been, am, and variations of that like should be, will be. Those are always going to be part of that passive verb. So here's an example from the classic writing book, Strunk and White. It's a great book to go back and review if you haven't looked at it in a while. So they give the example, my first visit to Boston will always be remembered by me, which is a really funny way, again, to talk. We don't talk like that, but yet in scientific writing, we write like this all the time. So that's in the passive voice. So how do you recognize that it's in the passive voice? Well, the thing being remembered, that's the object of the verb to remember. That goes at the beginning. My visit to Boston, that's what you're remembering. Then you get the passive verb. This is the will be remembered. And notice there's that will be in there. That's going to help you recognize that you're in the passive voice. You've got your to be verb. And then the agent, the person in this case doing the remembering, me, that goes at the end. So that's in the passive voice. To turn that back to active voice, you've got to invert that. So you would say, I will always remember my first visit to Boston. Let's do another example. So here's one in the passive voice. In this paper, the dynamics of human running on flat terrain and the required mechanical power output with its dependency on various parameters is investigated. Now you can see that that sentence is hard to read because it takes a long time to get to the verb. So we kind of don't know where the writer's going. And then of course the verb is in the passive voice. So is investigated is passive voice. We've got the to be verb. It's in the past tense. We're not told who did the investigating. That's left out of the sentence, right? The agent doesn't always have to be present. To turn this one into the active voice, then we have to come up with an agent. So who did the investigating? Well, of course, it's the scientist. So in the paper, you would just say, we investigated. So we investigated the dynamics of human running on flat terrain and the required mechanical power output with its dependency on various parameters. That second version is much easier to read. I still think we could probably edit that sentence a little bit more to make it more understandable, but at least now we know where the author is going because it's in the active voice. We had that earlier example about napping. The first sentence of that example was in the passive voice. So considerable attention has been paid to napping, has been paid. That is a passive verb too. Again, how do you recognize that? Well, we've got the has been, that's your to be verb. And then the verb here is paid. So who paid attention? Who has paid attention? I don't know. There's no agent actually in this sentence. All right, just one for practice. Again, if you're watching the tape version of the video, feel free to pause it and try this on your own. There's actually two passive verbs in this sentence. So it was concluded by the editors that the data had been falsified by the author. So how would you turn that into the active voice? You're gonna have to turn two things into active voice. So was concluded, that's in the passive voice. Had been falsified, that's also passive. To turn that into the active voice, you've got to make the agents here, the editors and the authors, have that role at the beginning. So the editors concluded that the authors falsified their data. All right, second tip on verbs is to use strong verbs. So choose the best verbs that you can. Verbs make sentences go in English. It's really what drives a sentence. If I'm ever struggling with my own writing and it's falling kind of flat, the first thing I do is I go through and I underline all my verbs and see if I can make them more lively. So I've taken an example from a novel, and this is a sentence that I edited just for illustration. So this is my mucked up version, and then I'll show you the original in a minute here. But it says, loud music came from speakers embedded in the walls, and the entire arena moved as the hungry crowd got to its feet. Now that's a pretty good sentence. It's pretty evocative. It's pretty interesting. But compare that with the original. The original said loud music exploded from speakers embedded in the walls, and the entire arena shook as the hungry crowd leaped to its feet. That jumps off the page at you because of those wonderful, lively verbs. Of course, in scientific writing, we often don't get to use really fun verbs like exploded and shook and leaped. Maybe in biomechanics, you get to use some of those, leaped and jumped and so on. But we certainly can do better in scientific writing than provide, show, is, the really, really boring verbs. Here's another example of a sentence with great verbs. So it says, NASA's intrepid Mars rover, Curiosity, has been through a lot in the past year. It flew 354 million miles, blasted through the Mars atmosphere, deployed a supersonic parachute, unfurled a giant sky crane, and touched down gently on the surface of Mars. And I just love that sentence. It's because of the great verbs: flew, blasted, deployed, unfurled, and touched down, and then the adverb gently. So that's a lovely sentence. It is really driven by those great verbs. So again, a few examples from my own writing where my editor improved my own writing. So I had written a sentence with a to-be verb, an are, which is really boring. Scientists have already discovered that some people are prone to being fidgety, which helps them burn more calories than others. My editor recognized that we had a great verb there, fidget, right? We could use fidget as the verb. So she rewrote it as scientists have already discovered that some people fidget more than others, which helps them burn more calories. And another one where she helped me out, I had written, after surgical removal, immune therapy should help clean up stray cancer cells and prevent cancer recurrence. So she changed clean up, which is kind of a boring verb, to after surgical removal, immune therapy should help eradicate stray cancer cells, which is a much more powerful verb. All right, third tip on verbs. So we have this terrible habit in academia of turning verbs into nouns. I don't know why we do this, but it's very common in academic writing to see lots of verbs that have been turned into nouns. Here are some examples. So obtain estimates of, has seen an expansion in, provides a methodologic emphasis, take an assessment of. Those, of course, could all be verbs. Estimate, has expanded, emphasizes methodology, and assess. So I have no idea why we write it as you see in the left column there, because what we're doing there is we're taking these nice spunky verbs like to estimate, to expand. We're transforming them into boring nouns, and estimate, and expansion, and emphasis, and we're pairing them with really boring verbs: obtain, has seen, provides, take. So there's absolutely no reason to do this. So if you catch yourself doing that, think about that. Think about how you can turn it back into the verb form. And we saw an earlier example, the one on immunotherapy. One of the reasons that sentence is so hard to read is actually because it does this turning verbs into nouns. So it's written with a lot of nouns that could be verbs. So selection, activation, expression, reinfusion. Those are all nouns that could have been verbs. Select, activate, express, reinfuse. That's a major reason why that sentence is so hard to read. Compare that to the alternate definition that was much easier to read. What did they do in that definition? They turned those, or they used the verb forms rather than the noun forms of those verbs. So they said expanded and reinfused rather than expansion and reinfusion. That's part of why that second definition is so much easier to read. All right, the last tip on verbs is to make sure that your subject and your main verb are kept together at the start of the sentence. So we have this terrible habit in academic and scientific writing of writing really long subjects. I see this all the time in scientific literature. Remember that your reader actually doesn't know where you're going. They don't know the point of the sentence until they get to the verb. So if it takes too long to get to the verb, you are going to lose your reader. So watch out for this, because it's a common habit to write these really, really long subjects. Catch yourself if you're doing that. So just to give an example here, the results of variation of the applied chromatographic conditions, such as the bulk solvent composition, the concentrations and ratio of the acid and base additives, the presence of water as a movable phase additive, and the counter ion concentration furnished a better understanding of the retention mechanism. So there's a whole bunch of stuff going on at the beginning, and I'm lost by the time I get to the verb. Think about, what is the subject of this sentence? The subject of this sentence is actually the results. And then we get a bunch of interim description of those results. And then finally, we get to the main verb, to the predicate at furnished. Well, by the time you get there, you're already lost. So to rewrite this sentence, you want to bring together the main verb and the subject close together at the beginning of the sentence. So I rewrote this one as just simply, we gained a better understanding of the retention mechanism by varying the applied chromatographic conditions, including, and then I go through the list then. So it's better to put that list at the end of the sentence after the reader already knows where you are going. All right, one for practice again. If you're watching the tape version of the video, feel free to pause it and see if you can tackle this one on your own. But this one says, the lower external joint moments at the knee and hip joints, the lower mechanical work at the knee joint during stance, the lower energy loss in the prosthetic ankle joint, and the lower total body mechanical work in each ground contact leads to the assumption that running with the dedicated prostheses allows the double transtibial amputee sprinter to run at the same level of performance as able-bodied controls, albeit at lower metabolic costs. So again, you kind of get lost in this one because when you start to read it, you end up in this list of things and you don't know where it's going. So what's the subject of this sentence? The subject of this sentence is actually that entire list. The lower this, the lower that, the lower that. This whole list of things is the subject. We don't get to the main verb, to the predicate, until we get to leads to the assumption that. And it's actually kind of a confusing verb there. I don't really know what's meant to leads to the assumption that. It's probably not the best verb choice there. So think about how you might rewrite that one to bring the subject and verb closer together at the beginning of the sentence. There's probably a lot of ways you could edit this one. The approach that I took was to realize that what we're really talking about here is the prostheses. That's actually the focus of these sentences. The prostheses lower external joint moment, lower mechanical work, and so on. So let's make that the subject of the sentence and kind of swap the order of this sentence to say that the prostheses allows the sprinter to run faster, and then give that list of items at the end of the sentence. So moving it around. So the prostheses allow the double transtibial amputee sprinter to run as fast as able-bodied controls while expending less energy because they lower external joint moments, lower mechanical work, and so on. So again, that list goes at the end when the reader already knows what that list is about, rather than putting it at the beginning where the reader is going to become lost because they don't know what that list is actually about yet. So those are just some tips for improving your scientific writing. Write with verbs, cut the clutter. My bigger, picture take-home message is, though, is I think much of the scientific literature, unfortunately, is gobbledygook. That is, it's written really badly. Again, if you're a young scientist, you should understand that if you're having trouble understanding the literature, it's a lot of it because it's gobbledygook and not because there's a problem with you. The poor quality of writing in the scientific literature, I think, is actually a really big problem in science, and I think it's something we need to address. And I'm trying to get young scientists to do a better job, and I really think that you all can do better than the status quo on this. I'll end with a few resources here. So as Stuart mentioned, I have a MOOC on Coursera called Writing in the Sciences. So what I've given you today is like the really, really short version of that course. If you want a lot more material on tips for good writing and a lot of practice exercises, I have an entire course in there. You can access all of the materials for free. You don't need to pay the fee to access the videos and to do all the practice exercises. I also have videos there that go into specific types of writing, like how to write an introduction section, or how to write a discussion section, or how to write a letter of recommendation or a personal statement. And of course, I also do a lot of training in statistics. So if you're interested in more training in statistics, I write a statistics column. You can find specific statistical topics there, like I have one on principal components analysis, logistic regression, confidence intervals. And then in February, I launched a medical statistics certificate program that I'm really excited about. So it'll give you some foundational training in statistics and data analysis and some training in coding in either R or SAS. And with that, I will pass it back to Stuart for questions.
Brilliant. Thanks, Kristin. Yeah, that was excellent. Really, really useful for me at least. So hopefully for some others as well. Yeah, it's the first question that's come in on YouTube. I'll read it out. It says, one of the comments that most supervisors or advisors advise to grad students is you need to read a lot and get to know your literature before you write a paper. So how does that sit with your kind of advice of don't emulate what you read in journals?
That is a great question. Yes, I think when we're teaching people to write, we always do say, do a lot of reading. That's how you learn to write. So what I tell my students in my writing class is, one of the assignments I give them actually is to read stuff outside of the scientific literature, to learn good writing from actual professional writers rather than other scientists. Of course, you're going to need to read scientific papers in your area, and unfortunately, a lot of them are going to be boring and hard to read, and there's no escape from that. You will need to read through some of that. However, I would highly recommend that you go outside of the scientific literature, pick up, the New York Times, New Yorker, whatever your favorite magazine or newspaper is, and when you're reading those things, read them a little bit more actively. That is, pay attention to how professional writers, for newspapers or magazines, how they write. We often read those things but don't pay attention. Like, think about how many sentences are in a paragraph, how many words in a sentence, how do they express themselves, what kinds of punctuation are they using? And I would emulate that and not what you see in the scientific literature. But of course, you cannot avoid having to read some of the scientific literature in order to learn your discipline. A trick I use, though, if there's papers that are really hard to understand, I will sometimes I have to like learn a whole new area because I'm going to write about it for a general audience. So I got to get in and read a bunch of papers. And before I interview those scientists, what I'll actually do is I will go try to find them talking on YouTube, because sometimes scientists, when you get them talking, actually do a better job of explaining things than in their papers. And so that's a good little trick. It doesn't always work, but often I can find them sort of talking about their science in a way that's a little more understandable. So you can find videos often to help. But yeah, read outside the scientific literature if you can.
Okay, yeah, I think that's really good advice, actually, something I've not really thought of much. But yeah, one of my main, I guess, philosophies generally is that you can learn something from everyone, or that most people, there'll be things that you can really learn from them and improve. Then there are other things that you kind of disregard and say, if I take a little bit of what's good from everyone and put it together, then hopefully you end up with a really good result. But yeah, I think looking outside of academic writing is possibly, yeah, some really good advice. Thank you. Yeah, second question that's come in is about be verbs. And it says, does it solve the problem if the derivative of be is replaced with a derivative of get or become instead?
Oh, instead of using to be verbs, using to get or to some
Become.
other,
Yeah.
or to become. Probably not. I mean, to be verbs have a purpose in the English language, so I'm not saying to never use them. It's just if you read scientific papers, often like every other verb is a to be verb. So it probably doesn't help if you're just going to replace them with other boring verbs. So if you replace your is with get or become or provide or show, it doesn't really solve the problem. Maybe it's a little better if all of your verbs say were to be verbs before and you've replaced a few of them. But yeah, see if you can be a little bit more creative and look for a little bit more lively verbs than that.
Okay, thank you. And then, yeah, another question that's come in says, do you think non-native English speakers use more passive voice than active, or do you think it's common across both native and non-native English speakers?
I think it's common across both. It's such a hard thing to write in a non-native language. Like, I can't imagine having to write a scientific paper in a non-native language for me. That would just be, it's just so hard. So I feel for students who have to do that. I do think that in other countries, often English is taught with passive voice. So they may be taught that they should do that. And therefore it shows up a lot in the scientific literature and scientific papers. But I would say that we have plenty of native English speakers who use passive voice just as much. So it's not a unique problem at all to non-native English speakers. But yeah, it's so tough to write about science in a language that's not your native language. It's really takes a lot of practice, and I admire people who do that.
Yeah, I'm completely with you on that. I've got the utmost respect for anybody that can write anything in a non-native language, but especially academic or scientific communication. Yeah, just in terms of, I think what you've presented is excellent, something I'm going to use probably with my own students in terms of scientific writing, but just almost not trying to get you to do my job for me, but in terms of teaching the skills that you've kind of presented, do you have any advice or tips of kind of exercises people can use? Or yeah, I guess if you, either as a staff or student, if you want to learn this, any recommended exercises?
Sure. Yeah, I mean, that's a great question. And so the way that I learned to write really is to work with editors, to work with really good editors and who would actually sit down with me and go through my writing line by line and show, like, here's how I edited this, and walk me through it. And I also learned by taking, when an editor sent me back, feedback, I would go through and sort of study that feedback, because that is how you learn. You learn from people who know how to do this well. And so what I try to do in my writing class at Stanford is to spend time really giving very, very specific feedback and a lot of edits to students. And I think if you can get somebody with enough experience to do that kind of very hands-on editing, not this kind of editing where you say, well, it's confusing here, rewrite it. That doesn't help them to learn. Where you actually go through line by line with track changes and show them just how much you can cut and explain why you're making those edits. Best done in person if possible, maybe over Zoom right now. That's how I learned to write, really, is to get that hands-on direct experience, which is why I always think like my writing course would pair really nicely. Like if you use my writing in the sciences course as the didactic material of a course, but then you have a local writing instructor who could provide that hands-on editing. And it's not, it takes a lot of time from an instructor. So you can't, it doesn't scale to a huge group. You need somebody who can do 10 papers or 15 papers in a term. So that's one thing, that just like hands-on editing guided by a writer who has those editing skills. I do a lot of writing exercises where I have people swap. So peer writing exercises. And the best thing to do is not to take two scientists who are in the same lab or in the same field even. The best classes I've had in my writing courses, like a biologist and a physicist. And I've had them edit each other's work. And we do it in class. And I think one of the great moments for me in teaching was that I had a biologist and a physicist editing each other's work in class. So I kind of could overhear the conversation. And the biologist could not believe that the physicist did not know how DNA worked. And the physicist could not believe that the biologist did not know what a neutrino was. But it was like a little light bulb went off in both of their minds, because they realized, oh, wait, these are other smart Stanford graduate students. And I have completely explained things in a way that they have missed. And it's a complete miss. And so I think to the extent that you can get people to switch their, to edit each other's work, especially the further apart they are, that's a really good exercise. I also make my students, normally when we're not on Zoom, write on the spot in class. So I'll give them little writing exercises. And I think it's a good idea to just get writing and not feel, you have 10 minutes to write something. So it gets you feeling like, okay, there's no, there's no judgment. You're just writing something. It doesn't matter if it's perfect, because sometimes we just need to sit down and write, and we got to take away all this angst we have about writing. So I like to actually put them on the spot and make them write in class. But those are some things you can do with students.
Thank you. And yeah, just following on from what you said at the end there about putting people on the spot and actually writing something, could you talk a little bit about your own writing process? So you mentioned, and I really liked the idea of thinking about writing while you're out on a run or driving. But for example, do you just, like some people recommend, just writing anything for a first draft and then editing afterwards? Or do you think clearly before your first draft? How does it work for you?
Yeah, that's a great question. I have a very specific writing process, and I'll say everybody needs to come up with their own writing process for what works for them. I figured out what didn't work for me and what does work for me. So my process, like if I'm writing a feature story, I spend a lot of time on research. So I will spend a lot of time talking to scientists, reading papers, looking at YouTube videos, trying to figure out the space that I'm writing about. And then my writing process is to kind of figure all of that out ahead of time before I sit down to write the first draft. So before I sit down to write a first draft, I actually have pages and pages of notes where I have like the quotes that I'm going to use for scientists. I have the facts that I'm going to use, and I have those organized in a way that I understand, maybe not in a formal outline or anything, but just kind of on a piece of paper in a Word document. And I really map out in my head, what are the themes of this story? What is it I'm trying to convey? And I kind of know what's going to go in every paragraph ahead of time. And the reason I do that is that when I was a graduate student, if you came into my office at any given time, and I was working on my thesis, my office was strewn with papers. Like, I had one paper on my printer, and there's like 7 papers on the floor. And, God forbid anybody came in and moved those papers, because in order for me to write, I had to reach over to the printer and get the paper. This is back before when we still went to the library and photocopied things. And so it was a really terrible writing process, because it would take me all day just to find the paper that I needed to get the fact from. So I figured out, when I later was writing professionally and I had real deadlines and not academic deadlines where I actually had to do things quickly, that was not very efficient to have to be always looking for that information. So I believe in getting that information gathered in one spot electronically before I try to write. So that's one part of my process. I really know a lot about, I figured out the story, I've mapped it out in my head and sort of roughly on a piece of paper before I actually write a first draft. And I do spend a lot of time working through those ideas running and driving, not driving so much right now, but if I'm working on a story, I am very disciplined. I turn off NPR in my car, or I take off my headphones when usually I listen to NPR when I'm running. I put the headphones aside and I go without the headphones so that I can either while I'm running sort of work things out in my head. And I find running to be one of the best times to work out like the themes of your story and what are you trying to say. And I come up with sentences and ways of putting things, and I'll just write that doam when I get back on the run. And in the car, I actually talk the story through. I have a tape recorder and I talk out the story as I'm driving to work. And that's how I can work out a lot of what am I trying to say before I sit down to write. So I find that very efficient because I have to drive anyway, and so it doesn't add any extra time to my day. And then I like to write a first draft quickly. Now, this is not everybody, but I like to sort of know what I'm going to put in my first draft. And so I have my rule for a first draft is I have to get all the ideas down sort of in the order that I plan to put them in. And I have to write complete sentences. I do not allow myself to write incomplete sentences on the first draft, just kind of a vomit draft of every little idea. But I have complete sentences and I have the ideas in order. And I find that takes very little time to write. So I'm not sitting at the computer feeling all the angst of writing for too long. And then I have a lot of confidence that I can go back and make it sound pretty later. As long as I have everything I need there, I have to hold myself to a minimum bar of complete sentences, or it just becomes it starts to go off the rails if I don't at least have complete sentences. So yeah, that's my process. And people are different, but one tip I have for graduate students, don't be a perfectionist. So when I was a graduate student, I used to feel like I can't go to the next sentence until I got the last sentence perfect. And that just takes forever to write that way. And it's too, in the forest and in the trees and not in the, in the forest, it's too, it's getting you down into those weeds when you're better off just kind of seeing the big picture and then go back and make it sound good.
Thank you. Yeah, that's really useful actually. And I really like the idea of talking into a tape recorder in the car. It's something I've not thought of before, but I guess earlier on you said about listening to people presenting on YouTube because they explain better that way. And I guess it's the same thing, but just flipping it around where you yourself will explain things better if you're just talking. So you can then listen to that back later and almost, transcribe that on the page.
Yeah, I will sometimes go in and transcribe, I'll talk out until I get a few sentences that I really like, and then I'll go into my office and transcribe them. There's something less pressure about just talking to yourself in the car than there is typing something in a formal Word document where it seems a lot more pressure to me.
Brilliant. And for the last few minutes, I thought I'd play devil's advocate. But yeah, I guess some of the things people may say or people's fears may be around how they'll be judged or perceived by other scientists. So I guess, I wondered if you could speak a bit to this idea of, people might think I'm dumbing it down. They might think I'm not intelligent enough, or I might not meet the norms of the discipline and might be judged negatively because of that.
That is a great question. It's interesting. There was a great paper that somebody did in the psychology literature a few years back, where they gave very academic sounding paragraphs and kind of more clear sounding paragraphs on the same topic to students. It's like one of these psychology experiments where they employ the Psych 101 students and asked them to rate how smart they thought the author was. So what was interesting is that they rated the authors of the clear, simple paragraphs as smarter than the ones who wrote the very complicated academic sounding. So we have this perception that if we don't write the way we think the scientific literature is, that we're not going to be considered part of the club. But in fact, people appreciate readers, journal editors, journal reviewers really, really appreciate clear, easy to read writing. So if you can just convince yourself of that, I work with a lot of journal editors. Believe me, they want clear writing. They do not want you to write in that academic style. So even though that's the norm, it's recognized that that norm is not a good way of writing, especially if what you write is not understandable. In terms of feeling like you're dumbing down the science, I often get that question of well, if I write in plain English, it's not, I'm going to sound like I'm dumbing things down. So you can write in much clearer, plainer English with smaller words and still convey exactly the same idea just as accurately without all the jargon. And I actually think it's harder to do that. I think you have to understand the science better to explain it in smaller words than to explain it in bigger words. So when I write for a scientific audience, I get to be a little bit lazy because I don't have to think through the science too carefully. I can throw in some jargon. When I have to write something for a general audience, I have to think through the science much more deeply, actually. And I think that comes out in your writing. When you explain something that's a difficult topic clearly, people don't say, oh, well, you must not be very smart then. I think they really appreciate that level of understanding that you're conveying. And then, yeah, in terms of the norms of the discipline, it's unfortunately, we do have this norm that the writing is very poor, but I think we should all strive to do better. And I often get the question from scientists, well, you know, if I try to write for too general of an audience, it's not going to sound like scientific enough. I'll tell you, I teach a summer course where I try to train scientists to write for general audiences. It's just a one-week crash course. We have them write a piece for general audiences at the end. They can't do it. It's because it's so hard. You are so immersed in your science that even if you try to write for a general audience, you might hit like 15 labs down from you instead of 2 labs down from you, but you will not hit general audience. And don't worry that you're somehow going to become too broad. It's never a bad idea to write for a broader audience. Yeah, so sometimes you get an advisor who pushes back and wants things in passive voice. I would tell my students, you can just blame me for telling them that they should put things in the active voice. Well, Dr. Sainani told me it was fine. So go ahead and blame me. Yeah.
So there'll be a lot of people blaming you next week.
It's okay.
I
don't have to work with your advisor. So.
Yeah. Why did you write iron? Yes, I think the only other, not necessarily criticism, but other possible counter argument I can think of is I've seen people saying that, like you talked about, I can't remember what term you used, but exciting verbs. So things like exploding and jumped. Is that kind of overselling our findings or putting subjective bias in rather than allowing the reader to make their own kind of conclusions?
Right. I mean, your choices of lively verbs within science are probably going to be less than, say, if you were writing for a general audience. So, I mean, biomechanics might be an exception because you probably do get to talk about leaped and jumped and lots of things that, you know, you often don't get to talk about. Like I'm writing about statistics. I don't get any leaped or jumps. So, yeah. So, but I think we can still look for verbs that are more lively than, you know, show, demonstrate, provide, and still sound scientific. So yes, I mean, we don't get the variety of verbs. When I'm writing for general audiences, I get a better variety of verbs. Some of those verbs wouldn't be appropriate for scientific writing, but I think there's some middle ground where you can still get some more lively verbs, like things like using the verb fidget or using the verb review or using the verb assess rather than provide an assessment or are fidgety. Like you can do better with verbs that work for the scientific writing.
Yeah, definitely. I think, well, I find your statistics writing exciting, but I'm not sure if that says more about me or the writing. But yeah, on that note, I think if we leave it there, but yeah, thank you so much for not only this, but also the previous talk as well and giving up, well, I was going to say 2 evenings, but for you, I think it's 2 mornings of your time. But yeah, thank you ever so much.
Thanks for inviting me.
Thank you.